Hey everyone, so nice to see so many of you here. My name is Olli Rantanen and I work for the National Land Survey of Finland. And so basically my presentation contain the background of our project, the quality assurance in our system, the topological rules we have implemented, the developed quality tool we use to control the quality. Then a little bit about the benefits of the tool, some challenges we faced during the development, and next steps. So there's a lot of stuff and a lot of text, I'm sorry for that. But yeah, basically the background of the project is that the National Land Survey of Finland has been developing this topographic data production system based on open source technologies since 2021. Most of the developed components have been related to job management, stereo mapping, and easing the workflow for the operators in general. And in 2022, we started to develop this quality tool for the operators, and our vision was to develop it in a way that it would be easy to use and informative for the operator. The quality checks would be fast and would happen with the operator's normal workflow. And that the quality constraints should be simple to maintain and change. So for the quality assurance in NLS, it basically, with this tool, it focuses on the logical consistency, but we also cover other quality elements in NLS, such as coverage, completeness, and up-to-dateness, but these are evaluated in separate processes annually. With the quality tool, these are based on quality rules like geometry, attribute, and topological rules, and we also control the continuity of attributes, such as like road links and the addresses they have and stuff like that. Then our production of work is guided by the severity level of the error, so we have 3 different states of severity, so basically info, warning, and fatal errors. Oops. Yes. So for the topological rules, those are based on QGIS, and we use ST disjoint, ST covered by, and some custom rules. And this custom rule set has been implemented by using the ST relay function, which is on the other hand then based on the dimensionally extended line intersection model. Don't ask me hard questions about that for the developers there, but yeah, we have been using that. Basically, we now use 7 custom rules, and some examples of these are line interior must not intersect polygon interior or boundary. So with this, we basically control how the ditches, so line geometry, topologically connects to leg features. Then another one would be feature A must border feature B, and this would be a whole line intersects polygon boundary. And with this, we control the topological consistency of lake and shoreline features. So how we have actually set up the rules, so this is a crazy large Excel, but you can basically friendly see it there, but it's an Excel format, so basically we have used all the object classes we have about 100, and just did a matrix from those and defined each and every relationship with each object class to another object class. And this has been defined by us, so the development team and the data team specialists, and in the NLS we have, I think, 7 or 6 data team specialists, so they are people who really focus on like certain themes like hydrographic terrain or road links and stuff like that. So with this matrix, there's 3 different classes to define. Basically, the red ones you see here. I'm sorry that you can't see the actual names of the objects there, but there's, for example, sea parts and lake parts. So basically, sea parts and lake parts have those red ones since they can't be on top of each other. So the rule works on both ways. Then we have the green ones, which are kind of like no checks, because these are either covered somewhere else with another rule, or they simply don't maybe have those many mistakes on them in general, so we don't even bother to check them basically. And the yellow ones then are the ones we check from like one side only. For example, canal and sea parts, so canal has to be on top of sea part, lake part, or waterways. So it has to be on top of those, but sea parts don't have to be on top of canals. So it works in this way. Then the major challenge there is to balance between just-in-case checks and useful checks. All right, I will take a sip of water. Yeah. Yes, so the develop quality tool. I'll show you a video just in a minute, but before that, just to introduce you to it. Basically, it can be displayed at any point during the workflow for the operator, and the results that you get from this are refreshed each time the operator does certain operations. I will go on those a bit further on my presentation. The results can be seen visually, and when fixed, will disappear from this set list. And the operator can always just also filter the quality results. And now the interesting part, if I get the video working, maybe. Yeah, I think so. Alright. So you can see the map of Finland there, and I'm zooming into my modification area, so basically my work database is here. You see the yellow parts, those are our fields, and we have a lot of those, so you can check those out. And when I click on that tool, I get the quality results on the map. So basically, when I zoom out, I can see also them in this point-like symbology. And we have info and warning state errors there now. And basically, I'm trying to show that there's an error there, and I'm going to take it out, like the topology error. So basically, I can always filter the results there for the errors. And you can filter by error types, feature types, and different attributes there. And also by different teams. So basically, just make the list a bit shorter for the operators. He can work on this area only specified for these certain objects. And then you can also show only the errors in your map extent. And so you see that filtering on the list there. Or visualize the errors sometimes and visualize them back if you want to do that. And when you click on an object, it automatically zooms to that object and selects the layer. So basically the error here is that two fields can be next to each other, they have to be combined, so to speak. So now I'm changing the attribute for this field to be unguarded. So hopefully when I click the garden there in a second and save the changes, you will see that it will disappear from the list in a couple seconds time. Alright. Yes? Okay. So yeah, it's not like real time, so to speak. Maybe we had to use quotation mark if there, but almost. So now I'm checking the road link there and changing some features. We also use constraints on the fields, as you see there, and help the operator to choose these because there's ranges and all that. So yeah, I'm just clicking the errors types there and putting some random numbers in. And in a second I will realize that I have to save the edits. Alright, yes. And it takes these couple of seconds and then it will disappear from the list again. And also the visualization, it takes a while, but now I have it selected when I click it, otherwise then it disappears from there. Alright, and then I register the changes, so basically this, I have the modification area, so when I register the changes, my work database is then transferred to the primary database, and the objects are again refreshed. Yes. So basically, how does it work? I realized that you can't see anything here. but basically the quality run starts in the background when the operator creates the modification area, and it will run again if the modification area is then modified, so expanded basically usually, or the operator refreshes the work or saves new edits to the work database. And the rules are based on the using SQL queries from the database, and we have developed this Java application that runs them in the database when one of these said functions are executed. And it can concurrently run the execution of the rules and manage the queue of items to be checked. And the rules are defined in this YAML format, which can be easily configured. And I have a picture of the YAML format there, but you can find all these also on our GitHub page. So basically, on the YAML, there are defined like the relationship between water discharge area and the lake point. So basically, it has all this information about the text that is provided on the quality tool, and also the languages that are available for it. Then the rule IDs, the unit IDs for the rule, and then the source and target filter. These are used then for if there would be an attribute that would be checked also from the topology. So basically, like the field object I just showed, the garden features can be next to fields, but fields and fields can be next to each other. They have to be the same field. And then there's the SQL there. And then basically only edited items are checked. So when you edit an item, it checks also the features that are connected with the, for example, topological change in the features. And basically we have developed this visualizing plugin called the Quality Results Graphical User Interface, which also Antero mentioned in the previous talk, where you can filter and view the results on QGIS. Some benefits of the tool, the golf is unrelated, I just like golf, but I just wanted to have a picture there. But it's like one tool to rule them all. Basically the quality checks can be handled in this single tool, which is easier for the user, so he or she doesn't have to use multiple tools to control the quality. And we can centralizedly handle the quality rules. So basically, when changes happen for the quality rules, for example, those data team specialists can ask for a change for the quality rules, so we can maintain those changes in our version control and our continuous development processes. All right, and then why we chose to do the quality checks on the database. So basically, we found out that it would be a pretty much better performance than in the backend service for client to do the same thing. And we can also do the fatal errors as constraints from the primary database, and quality can also be checked for data that is imported through different route than QGIS, which is important for us since we are currently importing data from the current system to this new system, so we can already check the data from that it has no fatal errors in it. And also the checks can be then run both in work database and primary database. Then for the challenges, since you saw the Excel, so we have over 100 different object classes, and since all of these have the defined relationship with each other, it's high maintenance for us. And we currently limit the maximum number of errors in the tool from 1,000 to make sure that performance is not bothered too much. But this might change soon, since most of the errors right now are from topological relations between shoreline and water features, and we need to kind of have a solution for combining those that they follow the one line topologically, because there's a lot of these little 1 millimeter switches to these, so they flood the tool, so to speak. And yeah, it's still a work in progress, meaning that we are currently evaluating which checks are actually meaningful and which are not. Right, and then for the next steps, so basically we are testing the performance with a large set of topological checks. We are adding, like, I think we have now made maybe like 20% of the topology checks for the different object classes. So we are adding the rest of them over this summer. So basically we will see how it really works in action, how fast it is and so forth. And upgrading the software to handle more than 1,000 errors at the time. Or smoothing the graphical user interface, which is a common problem, I guess, for this kind of tools. And alright, then there's the GitHub repository and some related topics here in Phosphogy from NLS. So basically, you can find all of these in the NLS GitHub. And we have published the front end of the quality tool and the Java library for executing the QGIS queries in the quality tool. And so for the related topics, Andrew just gave his great presentation about the improving QGIS plugin developer experience. And Eero is having his presentation tomorrow about the development of QGIS-based topographic data management system. And then Tero had his already yesterday about the evaluation and assessment of open source projects. So please check them out as well. Thank you.